Hi everyone, welcome to another quick session. In this session, we will discuss quantum key distribution. It is a cutting edge and fascinating area of cryptography. Uh, so, let's discuss what it is. Quantum key distribution is a secure communication method based on the principle of quantum mechanics. It's not about encrypting data directly but about securely distributing encryption keys. So the key concept from from this slide, that shared random secret key. So here you can see that one user, Alice, and another user is Bob. So they generate a shared secret key. So and it allows both of them to generate shared secret key, only they know it, not even the communication channel has knowledge of it. So quantum mechanics principle, if third party, for instance eavesdropper, that is a very important point in this discussion or on this topic. So interception. So if eavesdropper, any third party, tries to intercept the communication, it causes a disturbance. That is the important point. Why it is very secure? Because it causes a disturbance known as quantum anomaly. So this is because measuring quantum data like photons photons changes its states, so eavesdropping becomes detectable. So as soon as eavesdroppers try to intercept the key, the shared secret key, then there will be a change in state, and because of this, you will immediately know if someone is trying to intercept the shared key. And this is a huge advantage or advancement over traditional key exchange protocols where attacker can remain undetected. So we will come to that traditional way of key exchange. We have discussed in our previous sessions, but we will discuss traditional key exchange protocol briefly. So in this image or in this diagram, you can see Alice and Bob exchanging, for instance, shared key using a magic device that explodes or reports if anyone looks at it. That is the quantum effect. You can secretly observe without changing. You can't secretly observe without changing the outcome. So, uses of quantum key distribution, military and government secure channels, highly security financial transaction, future-proof encryption, resilient to quantum computer. So, so as we have discussed in our previous sessions, the traditional key exchange, metric, asymmetric, we have discussed those topics very thoroughly. So symmetric key, as we know, one shared key is used to encrypt and decrypt data. Risk: if you transmit the key over an insecure channel like internet, it can be intercepted. There are solutions out there, like you use Diffie-Hellman and asymmetric key exchange algorithm to securely negotiate a symmetric key over an insecure medium without sending the key itself. Right? So there are ways, but quantum key distribution, it uses principles of quantum mechanics particularly Heisenberg uncertainty principle and quantum entanglement. It enables two parties to generate and share random symmetric key securely. That is symmetric. But when you exchange it, when one user shared it through any communication channel, and if third party eavesdroppers try to observe or measure uh, quantum bits, the quantum state will be or is disturbed. So this disturbance introduces detectable anomalies. So both parties immediately know the channel is compromised. No asymmetric algorithm needed like Diffie-Hellman because the quantum properties themselves. So important note here. So the quantum properties themselves enforce security. So we do not need any additional way or additional method to exchange the key. So if we briefly do comparison about these two, traditional key exchange and quantum key distribution. So key exchange done over insecure medium with asymmetric encryption, like for example Diffie-Hellman, that is a traditional key exchange, right? So quantum key distribution done over quantum channel, so that is a quantum channel. So just one more note here: quantum channel, no asymmetric algorithm needed. Risk of interception present if no asymmetric encryption used. Interception detected immediately. So that is important point. And no uh, inherently detectable. So for instance, what I'm trying to say here, eavesdropping detection, so no inherently detectable. So if you use this traditional key exchange, then there is no property that if someone tries to intercept it, tries to fetch that key, there is no inherent detectable. But in this quantum key distribution, inherently detectable, that is the quantum properties. So that is a main or big difference, and that is the future. So we need to understand what quantum key distribution is. Thank you so much for watching this video. If you have any question, feedback, or your comment on this topic, please share in the comment section.